Good. Well, good evening, everybody. Thank you so much for being here tonight. As Todd said, my name is Barton Fiske. I'm with zSpace. So I'm Director of Technical Sales for zSpace. Next week, I'll actually be my one-year anniversary, so joined them in October of last year. I was introduced to zSpace by some former colleagues at Sun Microsystems. I spent about 20 years there. Nicole Yank obviously worked there. And they said, you got to see this thing. It's amazing. And it was a couple of weeks before SIGGRAPH, and they were exhibiting there. The product's been out since, I guess, April of 2011. So it had just actually hit the market at that point. And I got the demo and was pretty amazed at what I saw, and had some deep, long conversations with the management, and walked away from what could have been a career job at Oracle for a startup that I had been thinking about startups for years and years, but never actually had the courage to go. But it was time to go check this out. So that's sort of my short history about how I got there. What we're doing this week is what we call a roadshow. So part of my title, part of what I do is evangelism for zSpace. And what we're all about is getting the word out, making people aware of what this technology can do. And so tonight we're just going to talk pretty high level about zSpace, the company, the technology. I want to make this interactive, so anything that's either not making sense or you want a clarifying question, please just dive right in. This doesn't have to be one to many directly. This can be many to one, one to many, however we want to structure it. Some of you got the demo earlier, and we're going to be around afterwards. So if you didn't get a chance to see the demo, please stick around. And those aren't the only applications we have. There's some sample applications. But part of the goal here is to find people that want to be developers, collaborators, and in this case, talking to Kai, what we're really also about is getting feedback on human interface, how we can do better at what we're doing, what you like about what you see, what you don't like. We've recently hired a chief design officer by the name of Carola Thompson. She's actually out in our Sunnyvale offices. And so a lot of your feedback I can funnel and channel directly to her, or we can connect you directly. But we're in the midst of, in my opinion, trying to solve one of the hardest problems that's been in 3D for years, which is a believable, compelling, functional user interface in 3D. And some of what you see there are examples of it, but it's by no means our complete effort there. So some top line takeaways, some things that we really want people to understand or remember about what you saw tonight is that what you see should be lifelike, should be believable, and at the same time it should be interactive, such that we've designed a system that you can work with, and the data and the experience that you're having feels interactive, responsive, and ultimately drives to a feeling of immersion, and that you have an immersive experience. And we really are trying to impact three key areas of life, which are learning, playing, and creating. So kind of a broad brush, but straight out of the mouth of the founder, these are some of the top level missions of what we're trying to accomplish here. So I want to play a short video. We put this together actually before ZCon, which is our user conference that was held in April earlier this year. And I want to remind people, and I'll probably mention it again, we actually have our East Coast version of ZCon on the 21st of October. So if you like what you've seen here or want to see more, we'll be at the Microsoft Nerd Center. If you don't mind, that would be great. It'll give me a minute to get this queued up. Let's just make sure we have some audio. Can you hear that? That's actually our founder. And he's actually working with some part models from SolidWorks. That's Lauren. I'm sorry I didn't introduce Lauren Schreiber. She's one of our marketing specialists in the back of the room with a pink jumper on. That's actually Jerry too. He's our stylist and input expert. He's a dual PhD. one of the brightest people I've ever met, an amazing guy. That's Lauren and one of our hardware designers working on a collaborative interactive application. Cool, if you can bring the lights up, thanks. So that's our gratuitous marketing piece for a 60-person company that has almost no marketing budget. That was put together by one of our interns. But one of the key technologies we were showing there is something called zView, which at the time when we made that back in April was literally just code that was in pure alpha. And we've been showing it there in the back of the room. One of the things about zSpace is it is designed to be and intended to be a one-to-one experience. What we're trying to do is take advantage of motion parallax as an additional depth cue, as an additional immersion cue. And so everything that's being rendered on that screen is being computed and being drawn precisely for your point of view. And we get asked all the time, you know, can I wear a pair of glasses and see what that person's seeing? Well, you can kind of see the stereo, but you'll be on an off-axis view, and it won't be as crisp and quite on. And so, you know, you have people standing in line, queued up, trying to see what everybody else is seeing. And one of our engineers sort of had this aha moment about, well, what if I could point a camera at the screen? What if we could define a region of interest? And then what if we could get the graphics off the graphics card at the same time and composite them together? So this is new software for us. It's something that, you know, we haven't quite figured out what to do with. But we see some interesting use cases in a classroom setting. If a teacher is trying to explain to the students what they're about to do, they can queue up, you know, a whole lesson plan that way. But we'd love your feedback about what can you do with that kind of technology. Another area that we're looking into is mirroring the display and connecting it to a 3D projector. And you can actually display that as a 3D projection with shutter glasses instead of the passive glasses that we use. The risk there is that if you have a large room of people and someone that's wildly moving their head around, you could potentially make a whole room of people very sick very quickly. But there are some use cases that might be valid there. And so we'd love to hear, you know, ideas and feedback on that as well. Yes? Sure, sure. So one of the things you may notice is the glasses that are used to view are, they're very lightweight, they're very thin. Those are referred to as passive stereo glasses. The method that we're using is something called circular polarization, which means that as the light leaves the display, we're alternating between a left eye and a right eye view and emitting circularly polarized light. And the light that emits for the left eye is passed through the lens of the left set of glasses that you're wearing, and your eye sees that, and the right eye is blocked and doesn't get that view. And then it's alternated with a polarization switch in the bezel, and then we emit the right eye, and the left eye is blocked. And we do this 120 times a second. So each eye gets a full 1080p frame of data at 60 times per second. And it's that level of speed that the brain then fuses that into a 3D view. And we chose to go that way for a variety of reasons. One is we get very high luminosity out of the display, and we can control that. We're not limited by the glasses. Most of the active shutter glass technology today use lower resolution and use a lower frequency. They also tend to reduce the amount of light that's coming out of the display. And lastly, you have batteries and weight to worry about. So there were a number of ergonomic decisions that drove why we went the way we did. Yeah?
So like active glasses are ones with almost
correct.
batteries.
Yes. Generally, they're either recharged with USB or they're small, like hearing aid style batteries. And inevitably, they add weight, and inevitably, they get left on, and they just don't work. So the nice thing about the glasses is they're replaceable. They're very durable. If anything happens, we can trivially replace those. So the idea was to try and make this experience as unobtrusive as possible for the user. Ultimately, in the roadmap and in the technical roadmap that's available in the industry, auto stereoscopic displays are what everyone would like, which means no glasses. You just look at it and light is being emitted in a coherent way that you can actually see in 3D. Technology's getting there, but not at the price point we're trying to drive to. And this is one of the sort of things that we get pulled in many different directions. When we talk to Detroit and they want to do automotive styling, they want to do a dashboard and they want to do it at life size. It's not acceptable for them to do it at a display level. When we talk to schools and regional educational institutions, I see your question, they want a tablet that costs $500. And so that can be a bit of a challenge. So what you see is really 1.0, and it's a selection of choices that were arrived at. Sorry, I should have facilitated the microphone in the start of the discussions.
I actually probably don't need one. So my question is, since you have the requirement of the glasses, how does that affect somebody like me who already wears glasses?
Well, when I did the demo at SIGGRAPH and when I did the interview, one of the first things that surprised me was the design team had already come up with a set of clip-on glasses that go directly over your lenses. And those will, for most people that can see in 3D, even with astigmatism or correction, the clip-on glasses over the glasses seem to be adequate. So there was, in my mind, when I saw that, an extra level of thought that I wasn't expecting out of this company that I was just getting to know that sort of hinted to me that there's a lot of bright minds going on at this place. So thanks for the question. That's how we're doing that today. So the premise of the founder is that, and it's basically a premise of the company, is that we learn best by doing. It's far easier for the master cobbler to teach the son or the novice, the apprentice, how to do something by physically doing it and copying exactly what they're doing. So we're sort of just in this slide extending the metaphor. This is a picture of one of our business development reps' daughters, and that is a candid shot of their first moment of actually experiencing zSpace. And within a matter of 4 to 5 minutes, the older daughter is actually teaching the younger daughter how to use the stylus, how to move her head around, how to interact with what's there, and almost no training or no actual teaching of the experience. It's an intuitive experience. Yes?
You should put that on video and put it on your website.
It's a still photo, so we should get that on the site, but I don't think we have any video of it, do we? Yeah, we'll ask Pete. So we then extend this into the computer evolution, and some of us in this room, probably a lot of us in this room, can at least remember days where the display basically is that teletype there. It was a piece of paper with printing on it, and that was dominated by an entire room full of equipment. So we've evolved significantly, and now the inverse is true. Most of the computing capability is in the device, and the displays have gotten bigger. But honestly, this is about as good as we've gotten, which is 2D LCD displays. And there's some people who say that we're losing our ability to see when we're dealing with monitors because we're constantly looking at a fixed plane in front of us. We're not resolving depth in any way. Over time, we are not today able to direct photons of light in a coherent, not display-oriented manner, but this is a grab from Iron Man and Tony Stark building his Iron Man suit. But we think at some point in the future, this is going to be possible. But lifelike realism is really what we're about. And over time, we see a growing number of users, and by virtue of that, a greater number of applications that take advantage of this technology and greater business opportunities. And, no surprise, and part of why we're here tonight, there's also innovations in user interface over time, from multi-touch devices to things like Microsoft Connect and gesture recognition, and direct interaction with 3D data. So We are working on gestures. It's something that we have going on in our R&D lab. There's actually a video from NASA that's floating around right now. One of the NASA engineers is using some of our early gestural code and is directly manipulating data on the zSpace using just simple hand gestures. So I'm I've got both feet, well, I've got feet in either camp. I've been showing people zSpace for a year now, and just handing them the stylus and understanding that metaphor is universal across all languages. And for the most part, anybody that is mobile and can see can generally manipulate that object. And so I just step away and let them start interacting and playing with the device. I have to do almost no teaching of any kind in order for them to get it. It's going to be a challenge to decide what gestures represent scale, what represents rotate, what represents grab, drop. And so we don't have a universal dictionary of these gestures. I think it will come, but it's going to come from people such as yourselves and generations after that. So again, if your minds are thinking about this or you've got input and ideas, part of why we're here tonight is to have that discussion. So yes, question?
Let me bring you the mic.
Sorry. Yeah.
I had trouble with scale. I had no problem with the glasses. I had trouble with scale. The current convention for scale is pinch.
Right, right. The multi-touch, grow, shrink.
But pen doesn't do that.
Right. Yeah, that in and of itself is sort of the intersection of a simple intuitive device, but the user interface that that device connects to, if you will, not being terribly obvious or well-defined. And that was something I was referring to earlier, which is 3D user interfaces in general, in my opinion, are still in their infancy. And I've seen a fair amount that's out there. I can't say I've seen everything, but most of what I've seen in the virtual reality world just doesn't satisfy. So part of what we're trying to do is develop this skill set within our own employee base and begin to explore some of these ways of interacting.
Excuse me. Over here?
Yes.
I actually had a question. Like when I was demoing the software, I had a hard time actually rotating the models.
Okay.
And I mean that was probably the biggest hurdle for me at some points, like trying to imagine my arm actually rotating the model.
So which one were you using, or were you using both?
I tried both, but I'm saying more like the left computer mod.
So the sort of anatomical models, the biological models. Interesting. So we unfortunately have different methodologies for different user interfaces. So there is no consistency necessarily from application to application. I'm happy to show you afterwards and see if maybe we can resolve that, or if you are still having trouble, that's going to be valuable feedback. In general, the basic implementation of the stylus is to do essentially pick and drag, rotate and translate. Scale generally tends to be a function of you're bringing it closer or farther away, but if you actually want to augment the actual geometry, then you need another operator to do that, to either grow or shrink the geometry. Yes?
Can you talk a little bit about the stylus itself? How does the zSpace apparatus detect it?
Right. I'll talk about that a little bit more in the slides, if that's all right. I'll definitely cover that, and if it's not enough, let me know. But yeah, there's some interesting stuff going on there as well. Another thing, we are not religious about the stylus. I mean, that's what we put there. That's what could be agreed upon. But we've also integrated a trackball. We've integrated a 3D connection device. And so the non-dominant hand can actually perform some manipulations at the same time that you're using the stylus. So for example, you can grab a piece of data, if you will, and hold it with the stylus, and then with a trackball, you can further manipulate it. So we are open to several different ways and modalities. One of the things that we most frequently get asked when we show this to physicians is they want they want scalpel and they want clamp. They want 2 styluses. And there's lots of other situations where 2 styluses would be desirable. So we get that. We've gotten that often enough, we've actually put it on our roadmap. Oh, I didn't talk about that slide. Just sort of a summary of kind of where the 70s, 80s, and where we've gotten to today, to where we're trying to get to intuitive and direct manipulation with a natural interface. And we feel right now that this is a pretty high quality experience. And one of my first questions when I interviewed is, who's your competition? And at the time, and I still believe it's true for the most part, we are unaware of anybody that does exactly what we're doing. with a passive display, with a stylus, with that fidelity of control. And it's an interesting position to be in. I don't think it'll stay that way forever, but it is something that we can sort of at least say confidently. Yes, there was a question in the back. Yeah. Well, it can mean many different things. I think for me what it means is that I can walk into a classroom of 10-year-old kids and I can put the stylus in their hand and I can point them at the screen, and I have to do very little explaining of how things work. They pretty much figure it out themselves, or they already know how it works. They know how the stylus buttons work. They know how to scale things. It's quite surprising to see how little I have to interject my own input in order for them to have a positive experience. So I kind of start at that level. And as you get into the more sophisticated people that have done this stuff for years, have seen everything or think they've seen everything, we get more critical feedback, but they are able to pretty much manipulate and actually have a valuable experience. Part of the thing that pushed me over the fence into joining zSpace was I stood to the side while many people that have many more years of experience in the industry than me walked up to it and looked at their colleague and said, we need this in the lab now. We need to buy one of these now. And these are people that have seen everything. So for me, I can't say I'm the expert that has seen everything, but I did observe several people that I know have been in the industry and were blown away at what they saw. So those are some sort of rough qualitative metrics about that. This particular slide comes from Corolla Thompson, who is our UI expert. And I'll be happy to connect you to her if you want to hear some more on her thoughts about what that means. So some additional description of what we're trying to do. Smart use of 3D. Allow the user to focus on the content. This is one of the sort of phrases I've come up with, which is allow the domain experts to be a domain expert again and not have to figure out how to navigate 3 menu pick levels deep to find the one slider that does the thing that they're trying to do to actually interpret the data that they're looking at. This is something that's, I think, I find more and more resonant with people that do things like medical diagnosis or seismic analysis or data inferencing for business applications. They're tired of 2D menu interfaces that have way more complexity than they'll ever need to know. And all they simply want to do is look at their data. So this is part of what drives our philosophy in doing these sorts of things. And we want to move to two-handed interactions, and again, gestures, and other ways of interacting with the data. So this is sort of a sample in time, not a fixed implementation for what we're trying to do. So this is kind of a sampling of where we are today. We have head tracking and a stereo display. We can do one or two-handed input. We're looking at the second stylus and gestures. We want to be able to address multiple modes of input and experience through simple audio. And we actually have a vibrational motor in the stylus. If some of you were doing the demo on the right with the heart model, we actually vibrate the stylus according to the rate of the heart rate. And that freaks some people out. We've had people drop the stylus. We've had people just literally shiver and say, this is way too real for me. So it's quite interesting to see how just a simple vibrational motor can impact somebody's experience. We also use that for clearance and tolerance checking, for example, in an MCAD application where you're trying to fit a part in between two tight tolerances. We can vibrate the motor and tell you whether or not something's going to be able to be serviced or to be fit. And molecular biologists are looking at using this for drug design and looking at how bonds of molecules relate to one another. And then ultimately, on the maker side, probably developer is a better word, but we have a low-level SDK and obviously our website and resources, and we've recently published some 3D UI guidelines. These are essentially one place for us to put many of the lessons that we've learned to date and try and give those in a way that encourages people that are developing for the platform to follow these rules to arrive at a user interface and an experience that is graceful and elegant. So we'd love people to download that and have a look at it. Question?
Yes, this sort of relates to your SDK. I was noticing on your various demos that almost all of them allow objects to just move through each other, which is not
It's not real world.
not real world.
Right.
I assume your SDK includes creating 3D primitives and manipulating them, but does it include collision detection?
So actually our SDK doesn't really address content creation or manipulation per se. It is relatively low level. What we're providing is a set of C++ interfaces that expose the capability of the display itself. Most of the stuff that you're speaking about is actually already implemented in existing libraries or by applications that exist today or by following existing methodologies and algorithms for doing that sort of thing. So what you saw running today is actually built on the Unity gaming engine. And we actually also have an SDK for Unity. So anybody that's doing Unity development in C# can download our classes. And all of that stuff's free. If you just go to our website and sign up as a developer, we approve the account. You can get to the SDK. There's a bunch of C++ classes along with the Unity SDK. And we expose through those SDKs all of the basic capabilities of the platform. The higher level stuff will be in the 3D UI, which is coming. But in order to do the collision detection, that's basically implemented by the developer. And we do have some demos that show that. So we have a haptics demo which shows objects that actually behave according to gravity, self-detection, collisions. They react properly. When you move the stylus and you intersect with an object, you actually feel it. So it's all software. You can do pretty much anything you want. But people ask us, are we a hardware provider? Are we a software provider? What are we? Fundamentally, we make that display. But the way we position ourselves is as a platform provider. And we are trying to provide essentially a 3D user interface platform, if you will, or 3D stereoscopic platform. And then a lot of our value proposition is going to be borne out and driven by the applications that are built on top of that. So the application that you saw on the right, we call zSpace Experience. That was developed in-house. And it provides a kind of a sandbox, a canned series of demos that always essentially work the same way and speak to some of the markets that we might be able to play in. The demo on the left is actually an application. It's written by a company called Cyber Anatomy, and that particular application is aimed at K through 12 environments that want to, schools and educational systems that want to provide an immersive way of exposing that content to kids. There's also a university level version of it called Cyber Anatomy, which is a fully anatomically correct human being that can be used for further study. So Touro College in New York City is replacing their cadaver lab entirely. They're getting rid of it in a new building, and they're going to put a dozen of these zSpace systems in there and teach human anatomy on these systems in place of an actual cadaver. So one way to position this or talk about where we are is as a catalyst for reinvention. This is a quote from James Cameron, who was the filmmaker for both Avatar and Titanic. And he's had a couple of demos at this over different times. And his feeling was it would have saved him years in terms of pre-visualization for various scenes. So I believe that there is an Avatar 2 in process, and we are trying diligently to get a couple of those in front of his team. We had his lead director, is it director or who is, lead producer for Avatar was our keynote speaker at ZCon. And all of our ZCon materials and sessions are actually on our website. So if you want to check out that keynote, it's an interesting one to play back. So regarding markets, these are some of the key areas, not necessarily in order of priority, where we think there's a value proposition, where there's an application for using zSpace. For some time, we've been focusing on manufacturing. We've been working across the road with Dassault, and we've actually just got a release from them in their 3D VIA line. So they have sort of a virtual reality training simulation package called 3D VIA, where you can take CAD data or multiple types of 3D data and assemble them together and create animated scenarios or training simulations. So they've just released a commercial version of that application for zSpace. We're also working with the SolidWorks division, which is an acquisition by Dassault. And there's an application called eDrawings, which I kind of call a 3D PDF viewer for 3D objects. And we're working on a beta version of that. We should have that out in about another 2 or 3 weeks' time. And that's also a native implementation using our SDK. But moving down the list, we are a privately held company. We are venture-backed from Silicon Valley venture holders and a couple of other stakeholders. Actually, Scott Harris, the founder of SolidWorks, has put a sizable chunk of his fortune into us as well. And their direction for the remainder of this year and into next year is to focus on research, science, education, and medical. Those will be pretty much the core markets that we're going to go after and try and make an imprint in. And so that doesn't mean we're going to ignore these other areas. In retail, we actually did a proof of concept with Crate & Barrel, where customers could come in and visualize what their furniture would look like and apply different textures to the fabrics and different colors and different orientations of the furniture. And then entertainment and gaming is another area. We're not sure that the gaming area is ready for fully immersive stereoscopic interaction yet. There are a number of design challenges in the user interface, which you're probably well aware of. But we are basing a strategy around supporting gaming engines. So the Ogre engine, which is open source rendering engine, is supported. And actually the first version of that zSpace experience demo was running on Ogre, and we moved it over to Unity. And we've been getting asked consistently for Unreal. So we've been talking to the folks at ARA and Unreal about getting support for that. And the nice thing about having a gaming engine underneath is you can rapidly develop applications, and you can take existing content and pretty quickly get it running on zSpace in a short amount of time. So, kind of the four corners is sort of summing it up. We start in the top left corner with the zSpace display itself. We market, sell, and position that as essentially a display. You connect that to the rendering platform of your choice. We recommend at least 4 gigabytes of memory. Today we support Windows 32 and 64-bit for XP and Windows 7 and Windows 8. It's not on the slide, but we got all of the drivers signed correctly, so they'll work with Windows 8 now. And then the key part here is NVIDIA Quadro or ATI Fire Pro. And the important part is a graphics card that generates a quad buffer stereo visual. This is something that we specifically chose in that we wanted to be vendor independent. As long as a vendor supports quad buffer stereo, we don't have to worry about a vendor's proprietary implementation of a particular stereo technology. So in our case, we're taking a 1080p signal, and quad buffer stereo gives us 120 hertz refresh. And as long as the graphics card can display that, we can work with that. Another thing we get asked for is Linux. And we don't have Linux on the roadmap today. There is a workaround for it, which is to install a virtual machine that has our drivers that talk to our display and then use VRPN to talk to the virtual machine. As long as the Linux app renders in stereo, it will natively work on the display without any problem. So there are workarounds. The fundamental reason for that is a manufacturer of the cameras that do the input tracking never made Linux drivers, and as far as they're concerned, that's obsolete equipment. So we will never see Linux drivers for those cameras for the current version. We also recommend an Intel or an AMD multi-core platform. I'm actually using 2 dual-core processors that are probably 4 years old on my system at home. And it's working pretty well. Most of the performance, most of what you need needs to be in the graphics card. And if you just search on Google for zSpace supported graphics, that'll take you directly to our page that lists all of the graphics cards that we have tested to date. And there's probably 20 cards in there that we know work and work reasonably well. The oldest card that I've successfully used is an NVIDIA FX 1800. And that will drive the display, but it chokes on the graphics pretty quickly. And then in the application marketplace, this is just a small sampling. I've got another slide of a larger selection of vendors, but you can either get applications that are already out there and available today, Or and this is a very strong encouragement, we need people to develop apps or to port existing apps. And the basics of that are either using Microsoft's DirectX or OpenGL. And then you can also use the Unity platform or just develop from scratch in Microsoft C++. And in our SDK, we provide a number of reference examples that show how to actually talk to the tracking system, how to talk to the head tracker, how to talk to the stylus, how to generate the stereoscopic output. All of those are basic, essentially unit test samples. And then for the Unity side, we ship as part of our SDK what we call zSpace concepts, which is another sandbox style application. We load about 30 or 35 different geometry types and then provide a simple canvas for you to implement behaviors in. So we release the source code as part of that. So the entire Unity source code for zSpace concepts is part of the SDK. This is a pretty simplified description of it, but I wanted to at least talk about how we view the world in terms of software development. Any 3D app is going to have at least two blocks to it: the main application logic itself, and then the rendering loop. And the rendering loop essentially talking unchanged to the graphics device. But we have the ability to provide the math libraries and the transformation libraries in C++ as well as, if necessary, in the Unity side, and then the tracking system. So this is pretty much what comprises our SDK. All of that protocol goes over USB. So when you connect to a PC, there's only two cables. There's either a DisplayPort or DVI, which carries a video signal. It needs to be a very good quality cable because of the 120 hertz refresh, and we provide those cables with the system. But if you just happen to reach in your bin and pick out an old DVI cable, you may be surprised when you don't get stereo signal. So we recommend making sure you've got good quality cables. And then the protocol for the tracking system is simply a collection of floating point numbers that represent the location of the glasses in space, X, Y, and Z, and then roll, pitch, and yaw for the orientation, and the same for the stylus. So we send up across the USB wire the location of stylus in space and its orientation, and then those are retrieved in a polling loop from our SDK through the use of the SDK, the C++ classes. So how do we do head tracking? And hopefully this will address some of the questions. There's 4 cameras in the display. You can see 2 of them in the ears or the corners. These are infrared cameras. They're actually standard NTSC resolution. They're not high-resolution cameras. And those are wired together on a USB bus. And so for head tracking, in the center, you'll actually see a ring of IR LEDs that are emitting infrared. And inside that circle are 2 more, on either side are 2 more cameras. And so what's happening is we're emitting out of the display infrared light that's hitting or bathing this person in infrared light. And the glasses, there are 5 reflectors. And we only ever actually need to see 3 of them. So if somebody has long hair or they're at an occluded angle, as long as we can get a reflection off of at least 3 of those dots, we can triangulate the location and the orientation. And that light just goes back into the system, and the cameras pick that up. And then they encode that. There's some small processors embedded in the system and a little micro Linux kernel that's doing all of that data gathering and transformation. So, and this will be probably one of the 2 most technical slides of the night, but basically we have a notion of camera space. Most 3D stereoscopic applications that you've seen today have a fixed camera, and this is why it's not terribly satisfactory for people that look at 3D stereoscopic displays, because there's no motion parallax. The objects in the real world, if I hold this up and I move around, I can see around that object. But when you're looking at a 3D object that's fixed with a fixed camera view, it doesn't matter where you move, you're still just going to see that same view. And the brain knows that there's something wrong with that. It doesn't physically hurt, but it does create a discontinuity, and there are studies that show that it affects cognition. So part of what we're trying to do here is make it easier to understand what people are looking at. So we made an assumption that the user's head is about here, which is about 16 inches from the display. We assume the origin is at the center of the screen. And then we essentially keep track of where the user is as a distance from this screen that we represented as a parameter called display offset. The number 1 in our world means 1 meter. So we actually have a notion of physical location that's accurate to within 1 millimeter. We know where the glasses and the stylus are in space within 1 millimeter in this frustum that comes out of the display. And we're able to track that and then provide that as location and orientation coordinates into the tracking system. The other thing to note here is this notion of a display angle. Most 3D applications today assume a 90-degree orientation of whatever it is you're looking at to the world that you're rendering. In our case, for a variety of reasons, making the cameras at the right angle to be able to track and to provide a convenient viewing angle, we fixed it at 30 degrees or minus 60 degrees, depending on how you like to do your math. So you have to take an off-axis projection into account when you're doing the math. And we actually provide in our SDK a whole set of classes that will do these transformations for you. You have to become somewhat literate in the pipeline and in the rendering process, but I've seen people take applications that they know very well and get it ported in about 2 days and working pretty acceptably in zSpace. So it actually can be done very rapidly. And then stylus tracking is very, very similar but slightly different in that we include in the stylus an accelerometer, and that accelerometer knows where it is in space relative to the ground plane. So the only thing that's really different is that our tracking space, or tracker space, is now oriented with the XZ plane, if you will, parallel to the ground. And so you have to take that into account when you're taking the coordinates in from the stylus. We still have a notion of display offset because that is still relevant for the stylus. And then the display angle is just carried forward. So in a nutshell, that's kind of how, at least mathematically and development-wise, how the system works. We've got a set of infrared cameras. Oh, I forgot to point out that the stylus, these tips are emitting infrared light as well. So those are visible to the camera. And at the end of it, all we're really doing is encoding that as location and orientation and sending that up the wire and giving you a set of classes that let you inquire that. So I mentioned this before, zSpace Concepts. This is our sandbox application. It's a Unity application. We provide all the source code for it. We have one sample demo scene. This is actually an exploded CNC milling machine. It's a little bit hard to tell. But the basic scenario, the setup, is that some fictional company makes CNC milling machines, and rather than make a bunch of them and put them on a desk and then let people tear them apart and potentially break them or ruin them, it would be just as easy to take the CAD model of it and let people interact with it in a stereoscopic, direct, manipulative manner and learn the orientation of all the parts and pieces. And we can bring this up after the talk, and you can interact with that directly. But we provide all the source code for it, and we provide that model for people to start working with. So the plug-in for Unity, this is a bit of an eye chart. I don't expect you to read all this, but basically you open up your Unity environment, you import our SDK classes for Unity, and by doing that, we have a set of utilities, user interface, and core capabilities that expose all of the sort of under-the-hood workings of the zSpace display. So you can do things like turn stereo on, turn stereo off. There is no standard, unfortunately, in the world for which frame is left and which frame is right. And if you're looking at a stereoscopic display and the frames are swapped, it's very painful. So most good applications provide a button that let you detect, by virtue of just seeing it, this is wrong, and hit that button and it swaps the frames left and right. You can do things like turn the head tracking on, turn it off, enable the stylus tracking, and a whole host of all of the things that we chose to expose in the SDK can be enabled directly and accessed directly from the Unity development environment. Another nice thing about this is you can author and work in stereo in the Unity editor. So you can use the stylus and you can actually wear the glasses while you're programming your code, and you don't have to come in and out of game mode every single time just to see how things are working. So this paper kind of wraps up many of the things that I've been saying and kind of hand-waving at. This is a paper written by Dr. Robert Patterson. It is our one white paper on our webpage today. And the thing that I like about it is it provides in one place most of the existing references to literature and studies that try to essentially quantify what we've been saying all along, which is that depth perception is enhanced with a stereoscopic display, and the fact that we also have motion parallax gives us some congruent perceptual cues that line up with what we're seeing. Proprioception is a nice fancy term for the fact that if you close your eyes and move your hand around in space, your brain pretty much knows where your hand is just by virtue of it's always been there before, and I think it's here now. It's probably there. So with our tracking system, if we provide good enough resolution with where your hand is and what we're drawing in the virtual space, you're more willing to believe that the things that you're looking at are actually real objects. So we take advantage of this as an additional sensory cue in order to sort of positively trick the brain into believing what it's seeing. So we're all about trying to activate parts of the brain that, frankly, until now, 3D systems have failed to correctly engage with. And this paper talks about some studies and talks about areas of research where this begins to validate some of this theory. And he's part of our board of advisors. He's not somebody that's actually working directly on the product today, but he's someone that we've been working very closely with and working on future directions as well. So I'll try to wrap up on the slides here. We're coming up on 8 o'clock. Don't want to keep people here much later than needs be. But we're all about building a community here of developers, of just enthusiasts that want to see this technology succeed, of partners, and content creators, people that want to see their content or experience their content in this space. So we have a variety of ways for you to get connected to us. If you do go to our website and sign up, again, most of the way that you connect to us is as a developer, but that doesn't mean that you're necessarily going to start developing zSpace enabled source code today. We promise not to spam you. We're very careful about not overflowing people's inboxes. But it is a way to stay connected to us, and then obviously through the website and through things like we're doing with this roadshow. And then, as I mentioned before, on October 21st, we'll have the ZCon conference at the Nerd Center. It's from 9 till 3 or 4. Ooh, 7? Oh, I'm sorry. That's the important part, beer o'clock, yeah. Because I have to be there at 7 a.m. But that'll be a great place to get more of this. Here's our obligatory wall of fame. We've kind of broken this down into the areas that we've been working with. Partners such as Autodesk. We've done a plugin for Maya, so if there's any Maya artists or animators out there, you can actually use zSpace to view the content. And we have a limited set of primitives that we've developed to enable extrusions in the Autodesk plugin. I mentioned we're working with SolidWorks, and one of the founder is an investor. Siemens has a product lifecycle management PLM tool called Teamcenter Viz. This is a tool for being able to look at a company's database of 3D parts. This has some collaborative capability in it as well, which is nice, so people in multiple locations can load data and look at it interactively. Not everybody has to be on a zSpace, but it's obviously potentially that much more interesting if you are. We've talked quite a bit about Unity. Working with customers like Boeing and Lockheed Martin, I end up being in Detroit more than I'd like to, but several of the big names are up there, using it mostly for automotive styling and for part level design reviews. And then the academia list is far bigger than that. It probably filled 2 full slides, but that's part of the nice thing I like about this privately held company. The board is very hands-on with this company, more so than I've ever seen in any other startup. And a lot of them come from strong academic backgrounds. So they have directed us to go out and engage, find collaborators, university researchers, and go place as many of these as we can. And then we're building out a network of resellers. We're primarily focused on North America. And in order to reach the rest of the planet, we're working with established resellers. ISID in Japan, Eon Reality covers a good deal of Europe and Southeast Europe. Inition is the UK and Australia. VR Logic, and is that? Oh, Immersion, yeah. We got a few others that haven't made their logo up there. They got to sign their agreements, but I talked some more about, about the community. One of the things that we do as a company is adopt open source projects. So we've done a port of PyMol, which is a molecular visualization, molecular sort of can create new molecules with it. So I'm not sure how you characterize that, maybe a molecule editor. But we put in support for haptics for the stylus as well as stereo and head tracking. And then we're working with Dassault to get zSpace support into SolidWorks. And our first step will be with their eDrawings module. And I'll close with that. We've talked about ZCon, inviting you to come. You don't need the free coupon registration. It's free as of today. And this will be some of the speakers that'll be there. Michael Beauvais from MIT Media Lab. We've got 2 displays at the Media Lab today. So he'll be talking about getting 3D right. And then Garth Coleman is the product manager that actually sort of became the visionary for Dassault and the champion to put zSpace support into 3D VIA. And then Len Scroggin. And Lauren, have we added anybody else recently? We've got, huh? Awesome. There's Eaton from IPG Media Labs.
Yeah, Eaton from IPG Media Lab in New York City, coming from a retail perspective. Let's see, we have Valerie from RSC, which is from Chemistry Biomedical. We have
and Joe.
Steve and Jaden from Harvard Medical School and Brigham Women's. We have Brian coming from more the entertainment side, doing 3D and film.
Joe Laviola from University of Florida.
Yep, we have some universities.
Brown University graduate.
Yep, we have UCF and Wellesley there with their students.
Oh, Orit Sher, yeah, Wellesley's doing a fair amount of work with us as well. They're doing quantitative studies of the impact of zSpace in cognition and essentially proving that zSpace improves understanding and improves ability to work through puzzles and problems and real-world applications. So that's it. I'm going to wrap up. Appreciate everybody's time. Happy to take questions, and we'll be here a while longer to do demos. So thank you very much.
Hi, thanks. I'm going to speak kind of as a skeptic, but coming as I actually design 3D interfaces as well. I work at Autodesk. You said you don't really have any competitors, but I'd say that maybe your competitor is current 3D systems, because in video when you have the user looking at the skull like this, I'd argue that that viewpoint can be obtained very easily with the flick of a wrist, whether it's on an iPad or on a desktop. And I'd say if you had a doctor looking at an x-ray, she could, instead of sitting down at a desk with an expensive desktop and an expensive display, putting glasses on, she could get that same viewpoint on her iPad at a much cheaper price point. So, I'd like to see the research about if and how it improves cognition, because I get the natural interface aspect of this, of using your hands, and we've done a bit of this where using the natural gestural, but the viewpoint, I guess I'm not seeing necessarily the value. I think the technology is awesome, but I'm a little questionable about the value of sitting down, especially when everything's moving mobile, to have a very, very heavy desktop-based solution. I'd just be curious to hear a little bit more about kind of where you're seeing the possibilities. And you also mentioned gaming was not a focus, and I would actually think maybe that would be the killer app for this, because that's somewhere where the viewpoint, the immersion is so much more critical for the users. But
yeah, a couple of comments on that. I was absolutely a skeptic when I first started looking at this. Was this real? Was this going to be, a long? Was there a lot of runway in this technology and in this, in the patent portfolio and so on, or was this just going to be something that came and went? Reading the white paper did give me a lot more grounding about what was happening, but it would take a much longer, I think, conversation with you and some direct examples on the display itself to perhaps address some of the concerns. So I don't know that I'll do a credible job right now of convincing you otherwise, but Yeah, well, we're being pulled in different directions. As I mentioned before, Detroit wants a life-size, one-to-one scale. They want a 72-inch flat panel that can do stereo. They don't care about whether it's active or passive shutter glasses. They do like the head tracking. They do like direct manipulation. That configuration is going to cost $25,000, right? No matter how we slice that to try and manufacture that at any volume. As it is right now, the price point for the device is $4,000. And we started at $6,000 and brought it down to $4,000. We also have a leasing program that actually lets you get one for $1,500. So, right now what we're really trying to do is drive to a manufacturable and cost-effective platform. On the tablet side, yeah, whenever we go into schools and places that want to buy these en masse, they want it in the tablet form factor. But as you probably know, we're getting close with the Tegra platform, but there isn't a Quadro in any iPad that I know of today. You can get close, but there's no auto stereoscopic tablets that are available on the mass market. 2 years from now, probably very close. So there's a lot of things I can't say, but under non-disclosure and on our roadmap, we're looking at those things for sure. So those are possibilities. I mean, for me, the big one is auto stereoscopic. On the gaming comment, this was a surprise to me because I would agree. But it turns out that most gaming content of interest, successful gaming, is first-person shooter. And when you're doing stereoscopic displays and your first-person shooter, your eye is constantly fighting with foreground, background, foreground, background. And you actually have to do, or I'm told that you have to do a fair amount of trickery in where the eye is looking to keep stereo comfort at a rate that's acceptable and believable and enhances what's actually going on. Now, we took the canonical example from Unity, which is called Angry Bots, and we ported that. We actually did the stereoscopic modifications to the Unity core to allow for stereoscopic rendering. But you'll see in our implementation of it, we took it away from first-person shooter and we moved the camera actually up over the warrior's shoulder. And it made a very, very significant difference in the experience of what it was like to play Angry Bots versus just looking straight down the barrel of a gun. So trying to convince an entire industry to move their camera and to change the way that they design their content and present it is a significant challenge. Serious gaming and simulation, no question. This is a huge opportunity for us, and I think using the gaming engines is going to be how we do that. And we've got a lot of entree there. But on just the raw entertainment, and, it surprised me. The highest high-end gaming market turns out to be between $800 and $900 million worldwide for 2011, getting near $1 billion. And the makeup of that average person in that market is somebody that spends between $11,000 and $14,000 on their platform for the full boat, the double GPU, biggest screens they can find, fastest processors, highest bin separation memory, highest bin quality memory. They're spending about $10K, and they're refreshing this every 14 to 16 months. That is an addressable market. You can actually make products for that, but it's not something that we can singly focus on. And because we're privately backed, we pretty much have to do what the board tells us to. So right now, it's going to be simulation and education with the existing markets that we've already made entries into. Yeah.
Hi, sorry, ooh, that's loud. I'm actually from SolidWorks. I work on e-drawings.
Oh, awesome.
And I actually have a comment to this gentleman's question about the context. I also have that question initially, but I actually think that it's very important that you can tilt your head and appreciate a model in the context of the real world. I've interacted with sixth graders, teaching them about 3D and printing, and whenever I give them a 3D model that's been printed and just randomly hand it over, they will start spinning it around, and not knowing what it is, they couldn't really appreciate it. Just like anyone, if I were to have you look at an engine on the screen and you start spinning it around, you probably don't know which way's up, and you probably don't know what's what. But if you give the object to someone with a clear what is down, And then if they want to appreciate different aspects of the model and know that this is the right side, this is the top side, this is the back side, they can tilt their head around and still maintain that gravity view, and it helps them to appreciate the model much better. So in 3D space, I agree with you, but if you're foreign to the object you're viewing, it's actually very difficult to understand what it is. And having that appreciation in context of real world is, I think, is very key. Right, you could still maintain that kind of surrounding, but I think we've had that issue with our 3D view before where we kind of dull down the background. You don't want to busy the model. You start having just a really faded horizon, and sometimes you forget if the sky is the ground or whatever. You could easily get lost. So that's one point I wanted to put that in because that's one of our experiences. A point I wanted to make about your UI, I noticed that from the video, I've used this device before, and I noticed in the video when the user uses the stylus to manipulate the model, when they want to choose a menu item, they're also using the stylus with the ray to select that. Why wouldn't you consider having two different kinds of, like a gross action for certain actions and a really finite granular interaction for other things that need it. So if you're just changing menu items, it could be a very gross, like drop the pen right down to a surface and pick it. And then when you're doing really fine, granular dissection of the object, it becomes like that sharp ray. So that kind of difference between the granularity of the interaction might help in some of these interactions.
Yeah, there's no great answer for that. What you see right now is really best effort from the developers that were in many ways learning these techniques as they went along. Actually, if you get the chance, if you get over to Garth's side on the 3D Via side, Guillaume, and I can't remember Guillaume's last name right now, has done some very interesting work with the stylus ray and its intersection point, and it sort of flows over the object's geometry, which I've never seen before. Very interesting way to allow you to identify depth and picking ability as the ray goes over the data that it's picking. So very innovative use of the stylus ray there. If you go again to our ZCon archive, Jerry Tu is our lead stylus designer. And his talk on implementation of stylus as well as user interface methods is very, very good to watch. And then Corolla Thompson, I can connect you to her. She would love to hear your thoughts on that. We are right now in the e-drawing side of things. We're trying to at least get to a 1.0, but the stylus behavior there is pretty similar to what we've already seen. But it's sufficient, I think, and there's a fair amount of discussion still going on about how to enhance that. But I think when we get to the beta release of V14, we're going to have something that's well worth showing on zSpace.
So you talked a little bit about two-handed interaction.
Yep.
How far are you along those lines? Do you have working?
I'd say infancy, quite honestly. I mean, we have some ad hoc things that I can show you an app that has a trackball that you can manipulate the object while you're holding it in the stylus. That was done by one of our developers on a weekend whim. We don't have any right now. I don't have anything that I could publicly show that has two styluses working at the same time. We only have one stylus connector, and so we only support a single stylus. There's no reason the tracking system can't resolve that, and there's no reason that we can't figure that out. It was just at some point we had to stop the discussion and the argument and get to 1.0 and get it out to market. So that's kind of what you're seeing there. But we are around the corner from evolving multiple parts of the hardware platform, and that's why the TAP program's kind of cool, because for $1,500, you get the whole thing, you get the software, you get access to the beta drivers and the development team. And as long as you keep that subscription renewed, every time we make something new, we just you send us back the old one, we send you the new one. So it's a way to stay current on that curve.
I've got a question.
Yeah, okay.
Is it possible to, what information is transferred along the wire connecting the stylus? Could you ever have a wireless stylus?
That was one of my first questions, is like, really, a tethered stylus? What, this is so 20th century. And I asked that question directly during the interview. So again, one of those things, many, many heated discussions over the course of lots of engineering lunches. Bottom line thinking was, it's already there, it's affordable, we don't have to license Bluetooth, we don't have to put a battery in, it doesn't walk away. You know, somebody's going to walk away with my stylus, and then I'm dead in the water, right? So that's kind of a lame answer for that one. But weight was a big consideration. Putting a battery in, and then you have to recharge it. How do you recharge it? How long does the charge last for? When the charge starts to go, you lose your tracking fidelity altogether. So it's kind of a binary, you know, it's going to always work. We can put full power, and we can get very high sampling across that wire, accurate sampling into the USB bus by doing that. So those are some of the design choices, but I absolutely encourage you to have that discussion with Jerry at length. And we are looking at wireless implementations, but again, nothing that we have on the market right now.
I'll try to be really short, but it isn't easy. With my game developer hat on, it's a massively multiplayer online game with an over-the-shoulder view. Those users don't spend quite as much money as the first-person shooter guys, but there's a lot of them, and they do spend money.
Yep.
We're aiming for a softer market even than that, where we don't want them to buy special hardware at all.
Right.
But what about 3D Studio Max? Okay. And we're also fine with OpenGL as our target. So that's the end of my gaming comments. But
Okay.
what I want in the user interface is I want the stylus to be this finger here, which happens to be on the left hand, index finger, and then I want 3 additional secondary contacts, which are my 2 other thumbs and the other index finger. And then it should be a pretty simple, intuitive interface where I can use this one index finger as the stylus and the rest to do supplemental things like the pinch, or we could do the pinch with the other hand.
So you're still talking about having an actual stylus in your hand, though?
Well, no, I'm talking about having my finger plug into a little stylus shell.
Oh, I see. Okay.
So it's like I'm pushing it in the direction of a data glove,
Yeah.
but I'm not going the whole way to the data glove with millions at
Right.
points.
We have a Leap, and we did sign up for the. So that could turn into a pretty deep black rat hole. We try very hard not to knock other technologies because it's all about the experience and it's all about what works for the individual user. We're not convinced that the Leap is the right thing for zSpace right now. The granularity, the tracking, the sampling, the latency that's in it, and the fact that so far we haven't found anybody that's using it a lot. You know, I can see some perfect use cases for Leap and for integrating potentially with zSpace. Museum kiosk is a perfect one. You know, you wanted to present some data. Oh, Leap. I'm sorry, Leap Motion. It's a small box that has the ability to sense gestures at a very fine resolution in terms of it can figure out where all 10 fingertips are in space. And the best way to do it is Google Leap Motion and look at their demo. When you see the demo, it's pretty darn impressive what they can do, especially with the ability to figure out where all 10 fingers are in space at time and provide near real-time location. But it turns out that the granularity is not actually that great if you're trying to do very fine motor skill kinds of things. So it's a debate I would certainly encourage anybody to have with Jerry. I'm not the tracking expert. I do understand how our tracking system works pretty well, but I haven't had a chance to get in front of a Leap. I think there are applications where you can merge these kinds of technologies. But you know, what I want to see is how far we push gestures and how accurate they get, and how quickly can I demo zSpace to someone purely with a gestural interface. And if I can do that, I'll be sold, and I'll be promoting it as much as I can. But for now, I too am a bit of a skeptic until I actually experience it.
I may have missed this in the beginning. Then how are you going to do gestures then without that kind of digit tracking? Where are you going to use this? I don't see the connection between the stylus and the gestures.
We're doing tracking of hands. You know,
okay.
I mean, the infrared cameras do see an image, and or we can use different cameras. But our tracking system is written in such a way that most of the acquisition method is orthogonal from how we actually present it up to the SDK. So as long as we can resolve what it is we're looking at and be clear about where those locations are in space, then we can assign those individual IDs, easily enough. So you can have, 10 tracking inputs if you want to.
Oh, so you can almost do what Leap's doing now.
Very close to it.
Yeah.
It's just, then you have to start digging through patent portfolios and making sure you're not stepping on anybody's IP and so on. But that is stuff that I'd have to find the video. We have shown it publicly, but it is a NASA engineer working with a zSpace and manipulating the Mars rover, I think, using just pure gesture control. It's pretty neat. Other questions? Comments?
So I'm in statistics applications nowadays, but in the 90s I did a lot of 3D modeling, rendering, animation things, and we saw a lot of, for our 3D app, we saw a lot of 3D input devices come and go. And it's interesting to see your integration of 3D stereoscopic displays and the input device. So for me, what you say about the very broad, but fairly shallow application space for this type of device is, I'm sure, very daunting. But also just the number of different systems that people have tried and failed. But I like what I see, so I wish you a lot of luck.
Yeah, one of the things I didn't mention, we support VRPN and TrackD. So an application that already speaks VRPN, if it was designed for Cave, for example, my favorite example is an application called Aviso, which was formerly AmiraViz, which was formerly Template Graphics, which was formerly Open Inventor. But the short story is they already knew how to deal with a wand, and they knew how to deal with head tracking, and they spoke it via VRPN. And I downloaded their application, and I beat away on it for 3 weeks. I couldn't get it working, and then they just gave me one little bit of corrective code. They gave me a wrong documentation piece, and so I couldn't get the tracker connected. I got the tracker connected, and in 5 minutes, I had that application working flawlessly. So it can be done. Not a single line of code changed, and I had it working, trivially. So some apps and people that have developed in this space that are, that have done this for a while, we can latch onto an app in minutes, and other apps can take a very, very long time, depending on the bureaucracy and the strength of the programming team behind it. But yep, very excited about what's now possible. And I got asked this question earlier today: why has it taken this long? Honestly, for that level of quality, that level of fidelity, the hardware was not available at a low volume price point until about 3 or 4 years ago. So most of the technology that you see in there is very recent, and it purely is just an integration of what was available at the time. So if we fast forward to what's being made now, or what will soon be available, Ultra HD is not unbelievable, and multiple input devices and just trivial gesture and voice control, probably not far from that either.
Cool. Any last questions? You can also ask questions during demo and dessert time.
Yeah, great. Thank you again. I really appreciate the chance to be here.
Thank you very much, Bart.
Now back to the front button. Grab the camera. Go into the heart. Let's see here.
Takes a little getting used to, but
There's the brain. Oh, there's
that brain.
See the camera being displayed on that platform. This camera is absolutely ready.
Since it's transparent, it's hard to tell.
This is all what I do way back is 3D stuff. So brings back a lot of cool memories. Had a really good time. New session. There you go.
Do a butterfly. No?
I don't know. Good. It'll be fun. You're gonna pull the wings off the butterfly? Good plan.
First, can you fly the whole thing around? Yeah, that would be cool. How do you put it back? Just you have to do this. Oh, you have to do that. Go back over there.
Although the stylus
Because it's pretty neat.
from my finger,
And now pull things towards you.
Oh, that's so cool.
Can you reach out and grab it with your other hand?
Yeah. All right, so that doesn't work so well with this video. Have you tried it yet?
I totally want one.
And I want one too. I really do. Why don't you give Paul a chance here? All right. Yeah. And then bring it towards you.
All the way to the glasses. So this Tony Stark, right? That's cool.
What does that say?
Solar system.
Oh.
So it goes right through.
Yeah, that's what somebody asked a question about that. So that's just the software. You can make it collide or you can make it go through it.
Oh, so the whole thing. So is there a way to so the gestures have now been seen? There's only 4.
I love when she does that, how it pops out there in the video.
There's doctor, models,
That,
architect.
I'm just awed by this.
That's pretty cool.
Ouch.
You guys do okay over here?
Oh yeah.
Put the eye on your face. So I see you can't get those little veins.
You can probably get those out
If you zoom in, maybe you
Zoom
can.
in? How do you zoom in?
Oh, it doesn't have a zoom in.
I'm not sure.
Does it have a zoom in
Is
capability?
there
on this?
zoom
Well,
in?
bring it towards you.
Or try the other buttons.
Bring it.
No,
Bring the
it
whole
doesn't
thing
have
towards
one.
you.
It doesn't have
Well, you
one.
can use the whole model if you.
Yeah, grab the whole model and bring it.
Yeah.
A little
There you
bit.
go. That's zoom.
Oh, there it is.
All right.
Whoa, how cool. Oh, that's a mirror. I didn't realize there was so
That's
much
so
in
cool.
the
The
eye.
rendered version shows objects in front of outside the screen.
Isn't that the coolest thing?
I know, but when we saw that in the slides in the video,
Yeah.
I assumed it was faked.
Oh.
But it never occurred to me that it was rendered rather than videotaped.
It's mixing the video.
Exactly,
right?
exactly.
Because here's my hand.
Yeah.
This is the coolest thing I have ever seen. Are you gonna say Okay, I have to walk away or I will be here all night. Oh my gosh, we'll take a little video of that. So this is zSpace. It reminds me of Iron Man and Tony Stark. Look how it jumps out the screen. How cool is that? Oh my god. So he has a stylus and he's actually interacting with this 3D model. Very cool.
In the car, as soon as you go through the car, you see the graph.
So the people of zSpace came through to BostonCHI today and talked about this product. Awesome. So look it up, zSpace. That's why. But yeah, it's cool when you're able to see the size of the heart. Oh my god. So detailed.
Put the camera here while I'm doing that. Does the watch do anything cool other than this?
Scale it. I think it's the same quality.
As soon as he put the website up, I thought,
Lobster! Lobster! Lobster!
Eat it.
hey, how's it going? Play with it.
I'm going to. It's awesome.
And back in your little cage.
Get back in the
One
cage.
back in your little cage.
Aw.
All the antenna too. Come on, get that antenna in there.
The coolest thing I've ever seen. That is nice.
I just want to let me get this back. The cameras have a
Claw.
Mm-hmm.
Do you want glasses?
It is kind of weird.
Yeah, when they get the gesture down also, that is going to be nice.
React to where the stylus is. And
Saturn.
now, let go of it and let it fall. Move your head over here.
Yep.
And because the glasses move, the view changes.
Yep.
Yeah. I know, I'm starting looking at this, so I'm like, I like the animals one.
See you next month.
Great.
Yeah. All right. I'll take the ribbon.
All right, here.
I think the most awesome thing is the little camera that, with the screen. Like,
Game.
now, Barton mentioned that, what was it, Rage Bots or something like that? A game that had
Angry Bots.
Yeah. Is that on? Do you guys have that?
Congratulations on
Yeah, you should have seen me yesterday. I wasn't doing so well. Barton's like, let's do. We had 3 events yesterday. I'm like, oh yeah. All right, so the thing about Angry Bots is we have these here. You shoot with the stuff. So yeah, there you go.
Good night. Wow.
So the mask, I'm going to show you this one view over here. The best is when you go to this corner. I just wanted to say and you can look around.
Okay. That's fantastic.
Since it's in constant contact,
Yeah.
and since I will move down to some of my other projects,
That would be awesome. Thank you very much.
so I don't have anything in mind right now. But I have, if I'm one of the 4 people who really wants to be learning about 3D,
That's awesome. You want to jump in?
I'm good for now.
All right. Cool. Have a good night. This is.
Let's see.
So 3D effect on that. I mean, it's very strong. So
This looks like.
okay, here let's see on the bot.
Yeah, if you put on glasses, you'll be able to get a reason.
Right.
I
Well,
lost my.
it's like 3D in movies too, though. It's never unless you're in the sweet spot
Right.
there. Okay.
By the
yeah.
way, I saw Gravity in 3D. It was really good. Although 3D movies I find to be super distracting.
Normally I
in
don't
general.
like them.
This one was tolerable.
Wow.
I enjoyed the movie even despite the 3D, but the 3D didn't help. Now, will these explode on me if I don't shoot them?
No, I can win this game.
Okay, so they're more like cranky bots.
Okay, this is pretty amazing.
Yeah.
Wow.
Yeah.
Yeah, I definitely want this.
Yeah. It's incredible. Very cool.
Now this basically pretty much just works then, or how much work
So
was
Angry
there?
Bots, we have developed the plugins to be so easy to use. From the developer's point, they say drag and drop it onto your Unity game, and it will read the tracking cameras and whatnot. The only difficulty is when it comes to some apps weren't built so that they take time.
Now, Dr. Scherer,
Oh yeah, I love it. Yeah.
Yeah, I was good. Do you guys have like a partnership with her, or is she just interested in herself?
She has these she has a team that's working on it right now. If she's presenting at
Yeah, she's awesome. I think she's spoke at BostonCHI like 2 years ago.
Oh really? I think I'm bringing you back. Yeah, I haven't met her in person, but I've seen what they've been doing in it.
David's getting some video of the other monitor. Awesome. Good idea. You gonna put that in the video?
Oh, of course.
No, that's okay. Honestly, I'm gonna check it out.
Now wait, you can't see the skeleton now on this monitor, right?
Nope.
Because it's off camera. That's
Keep you guys too late.
that's freaky.
Put you back in your little coffin. Go to sleep.
Eternal rest. Should maybe put some happy music over the audio.
First step is to customize the face.
Oh, yeah.
And then when you pick the base, then customize. Okay.
Last one.
And then you can kind of drop in accessories. And when the accessories are inside the vehicle, this is the X-ray vision. What's cool about this one, which I can't really show, is it works really well with trackball, so you can rotate
Yeah.
it.
And you said you would integrate something with 3D Connections devices, the Spaceball, for those guys back in the 90s, yeah. My ears perked up when I heard that one. Okay. I'll see if they're still interested in this stuff, but yeah, I mean, this would be a total shoe-in for what they do. Yeah, military sims, military trainers are always looking for the kind of next pieces.
Well, that's especially since we like about the communities, because a lot of students stay in that industry is built on that. And this is our traveling case. But it was really great to meet you. And we'll maybe see you in early November or at the conference in 2 weeks.
I'm definitely going to try to get over to this.